Okay, I wanted to give a specific example of using area under to progress from acceleration to velocity and from velocity to position. And the specific example I'm going to give is free fall, where a ball is thrown at 20 meters per second up at time 0. The acceleration versus time is shown in the bottom graph here. I'm assuming that g is 10 meters per second just to simplify the numbers. So it's constant. We're ignoring air resistance. And so if you look at the v, y versus t plot, the velocity decreases uniformly at minus 10 meters per second, as you see in the figure right here. In order to find, for example, the decrease in velocity from 0 to 2 seconds, what we would do is we would go down to the a versus t plot and find the area, which is this area right here, which you can see is 2 times minus 10, so minus 20. So that means that since the area under the a versus t is minus 20 meters per second, 2 seconds times minus 10 meters per second gives minus 20 meters per second. Please look at the units. That means that the change in velocity from an initial value of 20 is going to change by this much, and so that gives the value of the velocity here. So in other words, 20 minus 20 is 0. Similarly, in order to find what the increase in position is from its initial 0, we can find the area under the v versus t curve, and so let's do that from 0 to t to find the change in position from 0 to t. So that's just the area under this right here. So let me spell that one out a little bit because this is kind of interesting. This area, this green area right here, is equal to 1/2, it's a triangle, times 2 seconds, that's the base of the triangle, times 20 meters per second. Okay, so first of all, note that this has the units of meters. That essentially what you're doing here is it's the average velocity. 1/2 times 20 is going to be the average velocity times the time taken, and so that's going to give a value of 20 meters, which is in fact the height risen by the ball. So this is a simple example of using area under the curve for free fall. Now, on all of these examples, I've gone from 0 to some time, 0 to 2, in fact, here. But you can take any time interval you want. You can go, for example, from 1 to 2 and use the same argument to figure out what the change in velocity is starting at 1 up until 2, and the change in position is starting at 1 second going until 2 seconds.